let us see what things are there in the instrumentation. See, absorption spectroscopy in UV and visible region is considered to be one of the oldest physical method for quantitative analysis on structural elucidation. If you consider the UV range, it ranges approximately from 200 nanometer to 400 nanometer and visible from 400 to 800 nanometers. There are three types of instruments under this chapter: photometer, spectrophotometer, and colorimeter. A photometer is an instrument for measurement of intensity of light or a relative intensity of a pair of light. That there will be two beams. Okay. Also, it is also called as an illuminator. It utilizes filter to isolate narrow wavelength region. So they will always utilize filters. The spectrophotometers, an instrument measures the ratio or a function of the two of the radiant power of two electromagnetic radiations, electromagnetic beams over a large wavelength. It utilizes dispersing element. It can be either prisms or gratings instead of filters to scan large wavelength region. Then next comes colorimeter. Colorimeter is an instrument which is used for measuring absorption of the visible region, is generally called colorimeter. Now colorimeter and photometer, they are very much similar. Photometer is in the range of both UV and visible, while colorimeter is only in the region of say visible light. Go to the next part, components of UV visible spectrophotometer. Now we are focusing on spectrometer now. You will require source of radiation, then you will require collimating system. All the lenses, mirrors, those any surfaces which bends the path length of the light electromagnetic radiation is called as collimating system. Then you have monochromators. You have sample holders or container which can hold the sample. Detector system of collecting transmitted radiation. Now the detector may not be handling very large amount of color and not able to you can say produce large signal. So that's why you may require amplifier or the readout device. Amplifier is different. Readout system is a device which gives you graphs. Okay, so these 6 components are important part of UV visible spectrophotometer, and this is how they are arranged. We are starting with the light source, then we have collimating system, then we have dispersing element. This is nothing but your monochromator. From monochromator, you have light passing through the sample container which has the sample. Then you have detector. Detector, it goes to readout system where the signal is amplified and converted into a number which is recognized by humans. Okay, let's start with source of the light. To start with, let's see what are the ideal sources. Ideal sources are having properties like it should be stable and should not allow fluctuation. If the source itself is fluctuating, the amount of energy absorbed and transmitted by the sample will fluctuate and it will cause error. So over the period of long time, it should give the constant radiant energy. It should emit light on a continuous spectrum of high and uniform intensity over the entire wavelength region in which it is used. I need to elaborate this point. See, let us draw a graph of the wavelength emitted by the source and intensity. It may happen that the source is not uniform throughout the wavelength range. Say around 190 nanometer, it is 190 say 200 nanometers. It is giving out wavelengths, electromagnetic radiation, but its intensity is very low. In certain region, the intensity is very high. So this is not ideal source. Ideal source should give out electromagnetic radiation of large wavelengths with same intensity. Okay, so this is your next point. Third point is it should provide incident light of sufficient intensity for the transmitted energy to be detected at the end of the optic path. See, we are interested in certain sets of wavelengths. So the intensity of those set of wavelengths should be sufficient so that even after transmission, the intensity remains somehow that can be detected by the detector. It should not show fatigue on continuous use. It happens with many types of bulbs. For elongated period of use, after say 1 or 2 hours of the use, they start fading. So it should not happen. The examples: tungsten halogen lamp. Now, this is very similar to the electric bulb that we use in our houses, that yellow colored, not LED ones, the one with tungsten wire, but the bulb is filled with halogens. The bulb is filled with halogen. हमने सुना भी रहेगा generally when there is a function, they bring those halogen bulbs. Okay, so this is that halogen bulb, but for instrument it is constructed slightly different. Its dimensions and size is slightly different. So I will read out points now. Its construction is similar to that household lamp. The bulb contains filament of tungsten fixed in evacuated condition and then filled with inert gas. Inert gas, halogen gas. Okay, the filament can be heated up to 3000 Kelvin. Beyond this, tungsten starts sublimating. Okay, it starts evaporating. It is used when polychromatic light is required to prevent its along with the inert gas, some amount of halogen is introduced. Sublimated form of tungsten react with iodine or halogen from tungsten iodine complex. This complex is important. This complex migrates back to the hot filament where it decomposes and tungsten is deposited back. So demerit, it emits the major portion of its radiant energy in near IR of the region. So it is demerit of it. Next, I think we are near to the end of the lecture.